All right, today in class we did a basic trigonometry review of the three main trigonometric functions that we come across. So in trig, we were taught this little helpful hint of SOHCAHTOA. And SOHCAHTOA applies to right triangles. So in a right triangle, we can begin with the SO. SO stands for sine of theta equals the opposite side over the hypotenuse. Next, we are going to discuss the CA side of things. CA stands for cosine of theta is equal to the adjacent side over the hypotenuse. Lastly, we have TOA. TOA stands for tangent of theta equals the opposite side over the adjacent. But what in the world does all of this mean? Well, we need a right triangle for this to make much sense. Okay, clearly my right triangle drawing could use some work, but in a right triangle you have one angle that is a 90-degree angle, and the side that is directly across from that 90-degree angle is the side that we shall call the hypotenuse. Now, to distinguish between an opposite and an adjacent, we need to highlight one of the angles. Let's highlight this one down here and call it theta. The angle that is across from theta is labeled as the opposite side, and the angle that's actually, or the side that's touching the angle of theta, is called the adjacent side. So that all makes sense. What about if I take a look at another triangle? All right, so we've got our right angle. I know that this would be the hypotenuse because it's directly across. Let's say this is theta. I frequently will see students say, okay, well, bottom side is adjacent and the left side is opposite. That is actually completely wrong because opposite and adjacent must be labeled with respect to theta. So since this is theta, this side over here is now the opposite because it's across from theta. This side is now labeled as the adjacent because it's touching. In a right triangle, another very important function is that we could label the hypotenuse as C and then the other sides as A and let's call it B. The Pythagorean theorem says that the hypotenuse squared C squared equals A squared plus B squared. This will be very helpful to us if we know two sides but no angles in order to solve for them, because then the hypotenuse, C, is the square root of both of the legs of the triangle squared. So in class today, I distributed some practice problems for us. I would like for us to take a look at problems 1 and problem 2 as an example to work through together. All right, so let's scroll up a little bit. Let's revisit SOHCAHTOA. I always write that at the top of any trig worksheet that I'm working with. Okay, so this first problem looks something like this. They say that that is your right angle. Over here is X. They tell us this angle is 60 degrees, and we know that this side is 9 meters. If I were you, I would go through and label the sides. We know that this over here is the hypotenuse. They do not tell us what the hypotenuse is here, so that's an unknown. All right, since this is our theta, X is going to be the opposite of theta, and 9 meters we will label as adjacent because it is touching. All right, so we are supposed to find X. That means we need to know the opposite. So automatically, we know we're either going to be working with sine or tangent because we need opposite. All right, so if we need opposite, and we know adjacent, that means we are going to be limited to tangent or TOA. We cannot use sine because we do not know hypotenuse. So what that's going to mean is tangent of theta is equal to opposite over adjacent. And if we plug in the values of this particular triangle, we know that theta is 60 degrees. So tangent of theta is going to be equal to x, because that's our opposite side, over the adjacent, which is 9 meters in this case. I'm going to leave the meters off just for unit confusion. I mean, you could put it there if you want to. All right, so we need to solve for x right now. All right, so how do we get x by itself? Well, we have to do the opposite. So I need to multiply by 9 meters. Whatever I do to one side, I must do to the other. All right, so now this is going to tell us that x is equal to 9 meters times the tangent of 60 degrees. All right, if you plug that into your calculator, I have that x should roughly equal 15.6. Don't forget your unit label of meters on here. All right, some common pitfalls. If this were a problem on Mastering Physics, a lot of times they want you to report to correct sig figs. If I look at the numbers that I was given to help me calculate this particular value, we know that we've got one significant digit in 9, and there's one significant digit in 60, although a lot of times we don't let the angles dictate our sig figs. So if I were to round this to 1 sig fig, that would make this approximately 20 meters. I don't know about you, but 20 is quite a bit different than 50 in my book, but if that's what the problem asked you for on mastering, then that's what you would put. Don't get decimal happy. I see some people say, oh, decimals make this really important, so I'm going to put a decimal there to make sure that we get that taken care of. Well, the problem with that is now you've made that 0 significant, which is a 2 sig fig number, which is not what you wanted. You just undid everything that you did. Another common mistake that I see people make is in this part of the problem. What I see them put into their calculator is this: tangent of 60, your calculator is going to put a little parentheses there, times 9. Don't do that, because your calculator is going to take 9 times 60, which will give you 540, and it'll take the tangent of 540. Very bad, all right? Make sure on your calculator, in order to get this number, you literally put 9 times the tangent of 60 degrees. Another tip that I gave in class today is that you need to make sure that you are in degrees mode, not radians. If you don't remember how to do that, go to math and change 2 degrees or settings. If you're struggling with that, let me know. All right, so next we are going to scroll up and let's talk about problem number 2 on your worksheet. Let me switch ink colors. Okay, so problem number 2 on the worksheet. The triangle looks more like this. Your right angle is down here. They labeled this side as 16.5 meters and this angle as theta. They also say this is 15.1 meters. Okay, let's write SOHCAHTOA. All right, let's label what we've got going on. So this side, since it's across from the hypotenuse, from the right angle, 16.5 is the hypotenuse. All right, since this is our desired angle right here, and 15.1 is touching it, that is the adjacent side. We do not, in this case, know the opposite, and we are not asked for the opposite. We're supposed to find theta. So what I know is the hypotenuse and the adjacent. Hypotenuse and adjacent, and I want to know theta, I'm going to use the cosine function. All right, so let's use cosine. So cosine of theta equals the adjacent over the hypotenuse, according to SOHCAHTOA. So cosine of theta, in this case, is going to be, our adjacent side is 15.1 meters, and our hypotenuse is 16.5 meters. All right. So when I plug that in, I get approximately 0.92. So cosine theta is equal to 0.92. How do we undo cosine of theta? You have to do the inverse cosine. So theta is going to be equal to inverse cosine of 0.92, which is going to give you an angle of approximately 23.8, and don't forget your unit label of degrees. If you rounded to sig figs, we have 3 sig figs in each of the sides, so I would keep it as exactly 23.8, and that is your answer. All right, so things to remember: always make sure you identify hypotenuse, opposite, adjacent. Figure out what you know and what you don't know so that you can pick the correct trigonometric function to help you, and have your calculator